So yeah, my name is Paul Druce and I'm a TME as part of the CloudVision team at Arista. So yeah, let's see this in action, all right? So let's see how this looks from a user point of view. So we'll just start off in terms of looking at some of the basics, right? So extend upon what Ryan's spoken about. We've got the data center environment here, we've got a campus environment. And if we just take a look at one of the devices to kind of give you a baseline understanding. So from a device point of view, obviously we'll get the basic system level information, but we also receive some streaming information around for example, the bandwidth that's been utilized. And this view is a typical view in CloudVision where you look at a metric, you get a bit of a view of the history, right? So a couple of other examples here to show, we collect compliance information and we'll show that updating in real time. Your common view is to see some graphs within CloudVision on one page. And as you kind of mouse over the graphs in the page, it gives you a mirror across all those different views to really help you to correlate, between different types of metrics. Now, down the bottom, we can scroll, we can widen the window that we're looking at, and we can kind of scrub back in time to get an idea of, okay, well, what does that window look like at this time window? And so what do the metrics look like? A couple other views in terms of a per device view. A couple of examples here, for example, CPU load. So one common use case is, okay, I had a CPU spike during the evening. What drove that? So looking at per process utilization. Even things like hardware capacity. So looking at the TCAM available on a particular platform and showing me a percentage of what's utilized. So as things change in terms of configuring and programming, for example, routes or ACLs into the TCAM, giving me visibility of that. And of course, configuration. We're not going to talk too much about configuration today, but let's show my running config and being able to look at a line in that running config and then go and search for where that's sourced. So in this example here, we're looking at that PTP config that was sourced in a configlet that was defined for that device. In terms of keeping a history of that configuration, though, we also want to track that over time. So if it's another element that as that changes on my network, we're tracking the timestamp of when configuration changed, and we're able to look back at that and do a diff view. So for example, between these 2 points in time, the lines in green show me what was the delta, what lines were added versus that previous snapshot, if you like, of the config. So that kind of gives you a baseline of a few of the elements looking at a device. But what would be, what I wanted to share with you today is a bit of a walk through an operational use case, right? So let's see how CloudVision can help in a few different scenarios here. So,
quick question, if you don't mind, before you jump in here. So CloudVision is a cloud management platform that manages the entire infrastructure, right? My data center and my campus environment, which to me, that's somewhat unique. I work with a couple other vendors who have taken a different approach. So I see a ton of value there in consolidating that. But when it comes down to, I think the term feature extraction was used earlier in the presentation, really getting from the raw data to the value, I imagine that there might be some challenges. So as you go through the demo here, I just wanted to understand, is everything viewed the same in your platform? Or do I have to define, this is a data center platform, this is a campus platform, or does it just infer the role of the device?
Yeah, good question. So when we talk about multi-main, we're obviously leveraging that single EOS that's deployed across any type of platform, whether it's the one I use sitting in a wiring closet, or that 400 gig, 800 gig router that's providing the backbone of some large organization. So the idea within CloudVision is that we want to maintain that single platform regardless of the domain where it's deployed. Now, CloudVision will understand the types of platforms that are deployed. As an example, with that hardware capacity I looked at, it knows what total capacity is available in that particular platform to display that information. Now, in terms of breaking down features that kind of layer on top of that, depending on the domain, we're exposing it within the single interface, for example, .1x configuration or status for campus use cases, but at the same time giving you visibility around VXLAN status for a data center, right? But we want to provide that in a single interface. Now, what you'll see in part of the demo, which will help address the question, is the ability to tag devices. So the user-defined tags that I can say, well, these devices are campus devices, these devices are data center devices, or they're devices in this data center or in this campus location, and then being able to use those tags in different views throughout CloudVision. So you'll get a good sense of that as we, hopefully, as we move through the demo.
What about wireless? So if we're saying that we can use this for whether it's a campus deployment or it's a data center deployment, obviously you also have wireless in your portfolio as well. Is that available in this today, or is that separate?
Yeah, so we'll get visibility around the wireless APs that we learn about in the network, whether they're our APs or otherwise. But if they are Arista APs, then we provide a linkage to then hook you, link you into the AP portal for provisioning things like SSIDs and getting visibility around the wireless.
Okay.
And we continue to build on that.
I want to jump in real quick and just point out how crazy it is that other vendors have different tools for managing the campus versus a data center. Because when somebody's having a problem with an application, like the problem could be anywhere on that path, and having different tools to see the different parts of the network for the same incident just strikes me as an extra challenge that you really weren't looking for. So I want to make that comment. Thank you.
Yeah, good point, Ken.
So I totally agree with that, but I think you used the term feature extraction as it relates to AI and ML. So are there challenges there? You know, when my data center switch starts looking for certain types of metrics that might only apply to a campus switch, or again, maybe it'll make more sense when we start looking at some of this in the demo.
Yeah, let's have a look through parts of the demo. You'll see different events created for different I suppose, different things going on that which may be more relevant for one domain versus the other. Perhaps we'll go through and we'll see how we see if we address the question. So the same environment here, we've got, let's look for an endpoint. So we've got a user calling in, they've got intermittent performance problems with their desktop or a particular host. So we can look for that in the network, and CloudVision understands where devices are attached. So it can tell us where a device and an interface learnt that particular host. It gives us information about that connection. For example, here we're seeing some, there's obviously a bit going on within that host. There's a number of discards. But then we can kind of drill into what else in terms of flow traffic. So we collect flow information into CloudVision based on S-flow information or IPFix or even in-band telemetry to give you a little bit more visibility in terms of the latency. So here we've got a kind of a chart view. We can look at a heat map of this so we can get an idea of kind of a broader picture of the conversations going on. So in this case, looking at those source hosts and the destination ports. There's a bit of activity there on the top left. We can change that to look at destination hosts. And this will really help us kind of drill down into, okay, well, there's a conversation going on here that we need to drill down and look a little bit deeper into. And of course, we've got all the details around the flow records, et cetera. But if we look at that case where we've got this particularly large flow going on here, and we filter that down. Now, what would be really helpful is to be able to display that across the physical topology. So we can go view in topology, and then this shows us our physical topology with our data center up the top in this case, and our campus network down the bottom, and they're connected together with some routers. And we have the flow information on the left here that based on that filtering, and we can click on a flow and visualize that flow, right? So now we understand based on that flow, there's traffic being sourced in the data center hitting this device within my campus, right? So we get hop by hop information, we'll get overlay, there's a key there with colors representing the flow bandwidth, but we can also use this to kind of overlay other information CloudVision knows about, right? It's collecting all this data in from the network. Let's display it to the user in useful ways. So something as basic as, what's the operational status of interfaces or the speed of interfaces, things that don't typically change much, but then things that are a little bit more, dynamic. So for example, the traffic throughput on a particular link. So you can see here when we hover over that link between the DC and the campus, at the moment, it's a low utilization. So how do I then troubleshoot my intermittent problem? And that's where the time series really comes in. And so in that case, if we look at some active events, right? So what other events are going on with my network? And so this very easily lets me pinpoint, okay, well, there's something going on with this switch with the connectivity to that particular host. So I can drill down into that and see the real-time traffic, but then also tells me that there's some active events going on. right? So there's a warning event here, there's an error event, output discards. Let's take a look at that. So an event, it shows us information about the device it was, the device that where the event occurred. In this case, it gives us the time window. So in this case, it's 20. What's the 20 minutes prior in this particular event leading up to it? So we get an idea of what the state of the network was prior, and then gives us information here. We can see there's some traffic counters, some drops, and we also get visibility into potentially microbursts that are going on with our latency analyzer capability, which is an EOS feature that really gives us a kind of that visibility into the congestion, potentially before it even leads to drops, right? So presenting this information that is relevant to the user for this particular event. Now, if we kind of step back to more the broader event view, here we're filtering on this particular device. There's a number of categories we can look at this through, or we can look at it across the time series. And let's have a look at a couple of these events. So we'll come back to connectivity monitor. That's quite interesting. But you can see there's some PTP events. But let's have a look at this event here in relation to the outbound utilization threshold. So this event has triggered based on the outbound utilization on this interface breaching 80%, right? That's triggered this event to then present all this user this information to the user. And like Ryan was saying, this could be triggering a notification based on some platform that's available to configure. Now, there's obviously some things going on here, but maybe in this case, what we would prefer to be a little bit more proactive is to get earlier warning about this case for this particular, say, set of devices. So here I'm using tags to the question earlier. There's some tags that have been defined within CloudVision elsewhere, perhaps as part of provisioning. And you can see that we're matching on a campus tag here. So we've got campus HQ representing that campus. So we're going to say for this particular event, only and filter for only the campus devices. And I've also tagged some interfaces to say that they are critical interfaces, right? So we might not want to do this for all devices or all interfaces generally. So by being able to configure these events, it gives us that flexibility. And so in this case, we've matched on those devices, those interfaces, and so we can kind of tune that threshold just on this match that we've defined. So that's one use of tags, and we'll see a couple of others. So now from then on, when that particular set of interfaces breaches, say 70%, we'll get a bit of earlier warning. And other events are configurable in this kind of way. So let's talk about another component within EOS that we expose in CloudVision, so connectivity monitor. Right? So connectivity monitor is something that is configured on the EOS device that sends probes out to destinations that we define. Right? So those destinations are typically, say, web endpoints. There might be a public cloud instance running somewhere. There could even be an internal device that's running a web server that we can connect to. So in this case, I'm connecting to a switch that's hitting our eAPI. And what that probe is doing is sending a HTTP GET request to those devices periodically, and then telling us about the response time. It's using ICMP to tell us about the jitter, the latency, the packet loss. And that information is something that's streamed as it's collected on the devices into CloudVision, enabling us to look at this as one of the views or one of the data points that we can then use to look at our network. Now, connectivity monitor is interesting because we also have anomaly events around connectivity monitor, right? So if we look at this event here, anomalies detected with connectivity monitor based on the latency on this device, going outside the bounds of what we consider normal. So if we look at this chart here, the blue is kind of the historical bounds of what we're expecting, right? It's the historical bounds of this probe that's being sent out from this device. And you can see obviously it's fluctuating in there because it's expected in terms of latency. And the blue line is giving kind of a mean, the mean value kind of going through this. Now, when this kind of peaks or bursts beyond what we consider normal, then we start kind of counting in terms of an anomaly score, right? So then we're tracking that score, and then based on a threshold that's defined for that that score. It's predefined, it's configurable. We can then create an alert an event based around that. And again, presenting some information that's interesting for the user to kind of use that information to go a bit further with the troubleshooting. So just one example, we've talked about predictive events. There's also anomaly-based events that we have available. All right, so thinking about that in terms of the information that's coming in, I've gone and looked at some events, but what about being able to display something? So in my NOC, I just want to create a simple dashboard to display this to the user. Now, if you look at this view here down the bottom, we've got the time window, right? So the time window is defined in this case based on the event that I went into, right? So that persists as I switch between views in CloudVision, so that I'm looking at this time window because I want to know what else was going on, right? So even on a dashboard view, that's the current state that we're looking at, right? So in this particular dashboard, these are all just built-in panels that are available that the user can configure, the compliance information, device information, even a topology view there. Now we can use another tag. So to the question earlier again, so just show me my campus devices, right? So I've created a common dashboard, and now I'm using those tags to filter that dashboard. In this case, to just show me the campus devices, right? So I could instead change that to just show me my data center devices. Now, it's telling me that I've also changed this to a live view in the last hour. There's actually another top talker here in terms of a flow that we've picked up on the network. And we can see connectivity monitor information coming in with that time window, but there's a heap of packet loss. There's obviously something going on. So the idea is to build up this information that's available to the user and really help it in the troubleshooting process. Now, we can add additional panels. Just give you a quick example. The panels could be specific metric based, like there's some graphs here or some tables, or they could be more summary based, so looking at more donut graphs and also the topology, etc. And we also enable the ability to use a query language under these panels for the super user who wants to take any state that exists within CloudVision and display that in a dashboard element, right? That's the AQL there, which is essentially use a query language to interrogate that central database that we've talked about and display information in real time as those paths change. But we want to make it easy for the simple simple use case for the user, and so point and click here as an example. We can add the top 10 interfaces that are being utilized, and again, a heavy use of tags are available here, so we can further refine this. Or in this case, we could just honor that dashboard level tag that we've defined, and very easily, and even within that existing time window, we've kind of added value straight away in that same dashboard by adding a new panel.
Are we looking at Arista hardware being that's where the telemetry is all coming from, or is there multi-vendor support here?
In this view, in this environment, I've just got Arista devices.
Yeah.
But as Ryan was mentioning, there's a basic level of information that we would get out of third-party devices, and a really valuable example of that is to imagine I've got this data center environment, this campus environment, and I've got a third-party vendor routing in the middle. So we will be able to display that information in the topology view, right? So that's probably one of the most, I believe, one of the most powerful reasons for getting that information, or useful ways of getting that information. And yeah, take some basic level of telemetry data out of those devices.
So you're saying basic level, so it would be fair to say if I have an all Arista world, this is amazing. If I have a mixed world, then it's going to be
We'll give you enough to fill in the gaps.
Yeah.
Right, and to basic levels, and understanding what that system is, the software it's running, collect some basic counter information. But obviously, we don't want to go too deep in terms of those third-party devices, because then there's a lot more to understand and invest in terms of those platforms. So at least for the time being, there's a collection of basic information.
Gotcha.
Yeah.
Okay.
Question here.
Yeah.
I noticed the packet loss was for AWS, Azure, those types of regions. is that just indicating those, like there's links in your Arista environment to those cloud providers, or is there something in the cloud that you're also pulling data from?
Yeah, so they're essentially, instances that exist within those public cloud platforms that I've used as an example. They could be anything, any web instance that is running anywhere, right? Private cloud, public cloud, where it's really used for that capabilities. Let's say I've deployed that at the edge of my network, that then connects to the public cloud, where I start losing visibility around what's going on, right? So if I'm probing that from the edge of my network to these public cloud instances, then I start to have more information around what the performance is beyond the edge of my network. And perhaps I can then use that for, if I'm, talking to a provider about the link or talking to a particular, service provider about what's going on. So it's really giving you a bit more visibility at that, at those layers in terms of collecting, the response time, the jitter, et cetera, which is hopefully helpful for you to understand that, which you may be learning about before a user's even complained about it.
Got it. Thanks.
I have a question my name's Mary. When gathering the non-Arista device information via SNMP, you mentioned that there was a sensor. Is the sensor just gathering the SNMP information? Is it offering some sort of value add?
Yeah, so Ryan, do you want to?
Yeah, the sensor is really responsible for turning a polling-based stream into a streaming system. So there's kind of two, that's one of the main use cases for it, for SNMP. The other use case is for like our cloud service. The cloud service can't go polling the switch. You want something local to that network. So it can act as like a local collector of that information that can then stream it up.
Thank you.
Most people's firewalls don't allow SNMP polling from the internet to come in and poll your device. So that's the collector is serving that function.
Okay, thank you.
Okay, excellent. Thanks for the question. So we're going to hand over to Dan now, and he's going to give you an example of extending this beyond CloudVision, so to that kind of third-party system. So